Hello, so we are having this panel on role of decentralized compute for next-gen AI. Can all the speakers introduce themselves? I am Shiv from Nani. We are an AI-based wallet. I would love to know how to integrate decentralized compute into our currently centralized product.
Yeah, sure. My name is Prasahant, and we have been building this entire supercompute network for a couple of years now. There are a lot of, so our main core thesis is like how we can combine both the data center computation and the retail computation together and reduce latency for the inferencing workloads. Basically, that is what mostly our focus is, not training. But on the other side, we are also focused more on fine tuning, but not training. So that is what we do at Spheron. Thank you.
Hi, I'm Gaurav. I'm CTO at IO.net. We basically are a hybrid of DeepIn and AI platform. We started with DeepIn around a year back, and now we have ventured into the AI side where we are creating the AI platforms for the builders to just focus on the business side of things and abstract away all the ML ops issues which are required to get your model ready and deployed on the infrastructure side. So we're in these two spaces, DeepIn and the AI marketplace and the model building.
Hey, whoa, sorry. Very, very loud. So my name is Mark, co-founder at Aethir. We build a distributed GPU infrastructure for AI and gaming companies. You can think of us as a DeepIn, where all of the compute that's contributed to our network is obviously owned by others. One thing that makes our network a little bit different is that every GPU connected into our ecosystem is enterprise grade. So it's sitting in a data center connected to enterprise grade network infrastructure. And we have kind of two types of cloud compute we provide. We provide compute on the AI side, whether it's for kind of training or inferencing. And then we actually have a cloud gaming element as well, where we're actually able to provide cloud gaming instances for PC cloud gaming and mobile cloud.
So between all of us, we have inference and training both covered. So the session will be good, I think, from that perspective. But what does decentralized compute mean to you? How does it differ from centralized compute?
I think it's not just decentralized compute. The term decentralized itself is quite different. We are not just a single entity controlling everything, while community powered. So for example, in case of us, like even in all of us here, most of our compute is not been owned by us. Like it's all been powered by community. That's one thing. Second thing is it has to be more permissionless with that as well. So that basically means like anyone who owns a certain compute power, they should be they become the part of network. So that's the other component for decentralization for us at Spheron. That is what we look for and thrive for. And the third and most powerful way is also to like allowing developers to chip in without, again, any bottlenecks, any KYCs or anything like that. So that's the thesis for me at Spheron.
I think in a naive way, you can define a DeepIn as a big community project where community brings their extra resources, which could be CPU, GPU, internet, multiple other resources. And for giving those resources, they get a reward back. And as and when the rewards comes in, the system becomes more fairer. And there's no single entity owning it because the community is driving it. Right? So that's in a nutshell, in a naive way, DeepIn is. If you try to go towards the Web3 terminologies, obviously there's a decentralized concept, there's a permissionless concept, and like security, we can define a number of things. But in a nutshell, it's basically a network which is driven by community. That community could be a normal person like you and me. That community could be literally DeepIns themselves. Like for example, Aethir and Spheron. That could be companies which have thousands of GPUs lying there because they just bought it at one time when there was a FOMO of AI and they wanted to build the product. And it could be college kids also. Now, as a platform, what you do is you grade those GPUs, mark them, score them, and depending on the kind of use cases and users are coming to your platform, you give it to them. But this is predominantly being driven by the community, and I think that's how the software would be built in future.
Yeah, I think not too much to add there, but I will make a clarification that I think is useful for people, right? I think everyone's well aware that, particularly in the AI space, there's a huge amount of benefit from having what we call co-located equipment, right? Equipment that's stored adjacent to other equipment that's being used by the same customer, right? And when you hear the word decentralized and decentralized cloud, you often think that means, okay, every time I want to access compute on that cloud, it means I'm going to get a little piece of this, GPU over here and a little piece of this GPU over here. And that's not actually the case, right? The phrase decentralized in its simplest form, at least as it relates to what we're building here, is more decentralized from an ownership perspective first, right? So actually we have contributors to our networks that own large amounts of co-located clusters, right? So you can still go in to Aethir or IO or Spheron and order co-located equipment, right? You can still get the same solutions, exactly the same solutions from the decentralized cloud as you can from the centralized solutions. And that's kind of an important distinction that I think a lot of people don't fully understand. They think that we're kind of over-innovating away from where the customers live, and that's not actually the case. There is some interesting innovation there, but yeah, decentralized doesn't necessarily mean not co-located, and it doesn't necessarily mean that you're going to be pulling compute from a variety of different machines distributed and located in different places.
Okay, so decentralized compute does not mean that the inference or the training itself is distributed. The training, the compute might be at the same location. What it means is that it is permissionless. Anyone can join in and become a node if they have enough compute to provide for the network. And anyone can become a consumer as well without doxing themselves and going through the processes that you have to go through if getting compute from cloud or something. So considering that, considering the compute is also co-located, I assume it is as efficient as centralized compute. Would you agree with that statement? Can decentralized compute compete with centralized compute?
I think Mark has well answered that. That is what he meant. Is like that is where people go in confusion state. Is like when you talk about decentralization, that basically means that performance is gonna hit. In reality, it's not the case. The machine is same, architecture is same, everything is same. The only thing is different is like instead of one entity or one person or AWS or anyone of some sort of centralized entities owning it, it's been owned by community. So that let's say you have a compute power, you are owning it and you are providing it. So your GPU doesn't changes, right? Just by connecting to us, it remains same. So, but I'll pause here if you guys want to add.
No, I think it's correct. So as I said, community could be data centers by themselves. So let's take a practical example. Let's say you come in and say, I need 1,000 H100s. So normally, as Mark was saying, what people think in their mind is that there are 1,000 GPUs, one in Bangalore, one in Pune, one in Delhi, so on and so forth, which is not the case. You can easily, in a decentralized platform, have more than 10 data centers, biggest data centers of India itself. And when you come and say on, let's say, IO or Aethir or any other platform that I need 1,000 GPUs. So you literally can hire those 1,000 GPUs in one data center. So they are co-located. The advantage which a deepen brings in is that it's a lightweight model. And why I'm saying it's a lightweight model is, let's say I am doing a business with Mark, for example, and Mark is my customer. Mark takes 1,000 GPUs for me in Canada. He's doing very good in business, and suddenly he says that I'm actually growing my business in India. I need 1,000 GPUs there. For any business, centralized business, it's a big amount of work to get those GPUs to Mark. Why? They have to come to India, rent a place, hire a team, buy the hardware from NVIDIA, wait for NVIDIA to create and ship, then my team to assemble it. There's a huge lead time, and then give it to them. In case of a deepen, it's a lightweight model. Like anybody in the community can come in, and when you have that demand of 1,000 GPUs in India, any data center which has 1,000 H100 can join in the network permissionlessly and serve that thing. So the advantage with this decentralized piece is bringing in is this lightweight model which enables multiple things. One, the iteration of this getting the CPUs, enabling these innovators in a fast way, first of all, is there. Second, because the provider didn't have to hire a new team and all these things. Normally in a centralized world, these companies, when they put in so much money, they attribute that cost to straight away the user. So that the user has to pay extra money. And now because it's a lightweight model, that cost is not going to the user, hence they're getting the cheap thing, the cheap GPUs, right? And like the advantages are like can keep going on. So that lightweight model is the main thing which is bringing the business side of things in the deep end.
Yeah, absolutely. The unit economics of distributed networks are very, very different to the kind of high capex model we see within centralized solutions. And the flip side of the ease of serving demand is also the ease of scaling your network, right? It's so much quicker, so much more efficient for compute to onboard into your ecosystem, right? If you're, in the Middle East, which is, very much focusing on being a bit of an AI hotspot at the moment, right? If you're a GPU owner in that location, you can say, oh, well, maybe I want to link up to a network like Spheron or IO or Aethir and expose my compute to a global market that might be interested in what I'm able to do at a local level. So it's a very, very cool model.
I'll also add one point on that. I think I wrote about that is like it also creates a very good opportunity of resource arbitration, where you just create that resource arbitration. Like, for example, let's say if you buy something in India, it might be a different cost versus if you buy something in US, the same thing. So imagine if somebody who's accessing an Indian device, they will be able to access it with the same cost what we'll be paying here, right? So that's also, I think, the part of unit economics which lowers the cost further down.
So it's really making compute efficient for everyone by like making it easier to do this arbitrage, which is very cool. But another reason people use like centralized compute is due to like privacy and security and regulatory issues, right? Like data privacy laws in Europe, I think require you to have the GPUs like co-located there as well, and the storage also in the same like area. So how do you address those things?
I don't think it's true. The only thing which I've heard is that in Russia, that if somebody is doing a business, they have to store data in Russia itself. In Europe, I think you're referring to GDPR.
Okay, taking away the regulatory aspect for this, because I have not researched this, but I do think there is at least a storage requirements for these things. But how do you address the privacy issue? Since it's any node in the network, are they, I don't know, able to access the compute I'm doing? Do they like know, is it encrypted? Things like that.
Why do you need encryption? So, okay, so that's where again people go wrong.
What if I want to have like the inference that's happening on the AI model? Maybe the provider is logging it, right? If I have taken a GPU from them, maybe they have I don't know something script on their hardware that notes down everything that the inference, everything that is being inferred. So all my consumers, as like all the Nani consumers, all the transactions that they're doing, and all the talks that they're having, is that available to those GPU providers? Are they able to do that? Do you have security mechanisms to prevent that?
So let me tell you one thing. In a solution design, I think Gaurav, you will also agree on that. Is like it's a design thing. It's not because you can never protect your request which is landing in a server, right? The moment it lands on a server, you know what just landed, right? There is you already get those TLS encryption, like SSL and all of those stuff, which is already been like, and then it goes through the system. Now in the system, if you talk about centralized systems, I little disagree on that point. Is like those are secure. Those are really unsecure systems you will ever see because they know what you are doing, and they can use that data to do tons of other things. And I don't want to open up a lot on those areas, but look around yourself what these centralized giants has been doing. So there are ways they are pulling down your data, right? Now, coming to the decentralized one, I think the question and concern is quite right, but again, it comes to the place where, for example, what Mark and what IO and what we all are doing along with is like, what Mark just said is like, we bring enterprise-grade GPU, right? Enterprise-grade servers. So what does that mean? That basically means like, those servers are already compliant for certain regulations. So you don't have to worry about that. The same goes with us. So when somebody works, let's say if you are working with Aethir or if you're working with IO or if you are bringing the data in, right? So we have two systems. So one system is called provider system and the other is called fizz nodes. So fizz nodes are the people like who need a non-compliant systems, but they just want compute, right? And they just get that. And on the provider hand, we bring only the tier enterprise and good systems who is already compliant. If they are not compliant, they won't be the part of that systems. So that's the thing. And like on the regulation part, again, on the security angle, because I worked in Web 2 earlier and I know that, so the Web 2 companies are not as good as we think in terms of
But
security.
at least theoretically, they have to follow those
So
rules.
it's software. Literally, you can literally monitor every bit and byte going to the system, right?
Yes, but
It's just not what you are doing, the other person also is doing. For example, if I take a machine from the data center, I exactly can know who's accessing that machine other than me. And if they're doing it, I can have monitoring on top of it. So even if people have that paranoia, most of the deep-in systems have this monitoring in place that who's accessing the actual resource. Like for example, in our case, when somebody creates a cluster, a Kubernetes cluster, a Ray cluster, or any cluster on our hardware, we basically monitor what is the usage of the hardware when we deployed our software stack. And we have the numbers around that when we deploy it, this is the percentage of CPU and GPU it's used. This is the percentage which is normally free. And if there is any delta outside this boundary, something which is happening. Same with the accesses, right? Over, above and beyond this, like there are multiple models. Like when you deploy a Docker, only Docker access is given to the person who's hiring it, not to the owner of the machine. Like if him have given me the machine and I'm deploying my Docker on that, I can make sure that that Docker access is only given to the person who has hired that machine, right? And vice versa also. I can actually create a Docker in a way that the person who has the access to it doesn't have the actual access to the machine also, if in case they have left their some personal data out there. So you can do a lot of stuff with software. And as he said, you should be actually worried the other way around with the centralized systems. What do you think, like when you actually have this Gmail and all your booking flights and all are going and suddenly you are traveling, a pop-up comes in, your flight is delayed by an hour. Like, what about the privacy there? Like, it's the other way around. In Web3, we build the system on transparency. That's the fundamental value we have. That's the value on which the whole ecosystem is built. So you should be more confident of building software on this side rather than centralized one.
I think it's a good question because it's natural, I think, for people that are trying to understand the deep in space to have this privacy concern with the fact that there's a third party involved. Normally, it's a direct relationship between a company that you've established an amount of trust with, right? Whether you should have that trust or not is a different question, but you've got a contractual relationship with a company that you somewhat trust, call it Google, Amazon, whatever, right? But here in this decentralized world, instead, you've got this third party. There's like an added counterparty risk. Is that risk actually there? Is it greater than what you see within the Web 2 services? I don't think so, and I think we've talked kind of a lot about that. I think when you start pulling non-enterprise grade equipment into the equation, when you start kind of pulling consumer GPUs and gaming rigs and things like that into your cloud, then things get a little bit more difficult, just because these are not pieces of equipment designed for enterprise workloads. They weren't built innately with the systems to kind of maintain that privacy and connection with those systems. So it gets a little bit more tricky there, but thankfully, maybe, the vast majority of compute workloads are enterprise focused now.
I'll just beg to differ on that front. The reason being is when people are looking for GPUs, as there are different kind of resources, there are different kind of users also, right? I think we're talking about enterprise because majority of our revenue and all these things come from enterprise customers. And enterprise customers predominantly will ask for enterprise grade hardware. That's true, right? But there are plenty of people, let's say a college grad, who is just doing his research and he's anyhow gonna make it a open paper, right? He doesn't mind using a community hardware also as long as it's super cheap. So let's say if I'm giving a GPU for $1.5 for an enterprise, but I'm getting a same model from a community member and I can give it for $0.3 or $0.4. And I actually tell it to the user that the security concerns are there, this is the hardware, this is the price. And leave it up to them. there are majority of users who want that kind of hardware also. It's a marketplace, right? And in the marketplace, you have n number of products, n number of users. We are kind of biased because our companies are valued, respected on the revenue which we bring. That's why we are normally biased towards enterprises. But I think in Web3, when we build companies, we just don't build it for businesses. We build it for community also. And when we talk about community, they are like big folks, they're normal folks, they're junior folks. So we have to think of everyone. And that's where these community hardware also plays a big role, I believe.
Yeah, just to, I think you just picked that well, and I was about to say the same thing. You covered that. So I'll give a very quick intro. I think most of Indian audience will relate to me as well. When I was in 2011, I did not had a laptop, like very good laptop with quite a massive amount of memory because India is always late in adopting all of these things. So for me, it is like even if I had to code, like I have to borrow somebody who has a bigger laptop just to compile the code. It was that tough. And then when I started looking back, because we talked to a lot of developers day in and day out, what we have realized, and while we were building Fizz node, because in Spheron we have two things, provider, which is more focused for enterprise, other is for Fizz. Fizz is more for retail focused. So when we were designing Fizz, when we were just talking to developers, the one thing which we hit upon is like, there was a guy who came to me and he said like, bro, like, do you really think I have $1 per hour to pay for these devices to like innovate around AI? I said like, I think it's a massive problem. I think Prakash and all of these guys are also here from our team. And when we heard this kind of problem, we said like, okay, so there has to be something. And then we went ahead and we said like, okay, let's go and build this Fizz stuff. And believe me, like today, I think a couple of developers of ours here also here who are building on top of Spheron and accessing these GPUs. And some of those, I think he's also one of them is here. And some of them, like, we met community members, RTX 4090, which is getting sold in the market at around 0.32, I believe, at a price. There are community members.
0.3.
Yeah, so.
IO, 0.3.
Yeah, but.
Final question.
I'll just wrap it up. But in Spheron, community is giving at around 0.14. So
Scale.
so it's a community power.
Yes, so I understand that you have a way of monitoring hardware for malicious access, like a malicious node, and you have a way of differentiating between known providers that are trusted providers and have to follow the laws of the land, and cannot be malicious, and untrusted providers. How do you see like tokenomics being useful for this? Do you have a mechanism for slashing malicious providers that are in your monitoring system identified as malicious? Do you have how do you use tokenomics to incentivize these models and also disincentivize them from being malicious?
I think everyone have different economics and
Yes,
the
I would
way
like
of
to
working.
hear each of yours.
Yeah, but for us, it was very straightforward. We built this entire trustless tiering system. So tiering system basically means like how much longer you are going to stay active in the network. So let's say if you are maintaining 100% uptime, then there is no slashing for you, right? The moment, and that too if you are, let's say, and then if you are 100% uptime in tier 6, no slashing. But the moment you go to, let's say, tier 3, and then your just uptime goes to around 99%, 95%, there is a slashing mechanism which will be enabled. So like that, we have all of this like economic system which is getting built in, and it's all automated, no manual effort which is needed.
Okay, so you focus on uptime instead of privacy issues with the providers
I think
and security issues.
privacy is, again, it's a matter of design choices and other things. If you are so compliant, then trust cloud. That I always say, because there's no way
We don't have to be compliant if we can have a tokenomics mechanism that slashes malicious providers,
So
right?
I'll tell you one thing. Software
And
also has a certain
I think you
limitation.
had a solution for
Can
monitoring.
you just be more specific in the question? If you don't mind, can you repeat the question?
So what I mean by a malicious provider is you said you have a monitoring system for noting if there is unauthorized access to hardware, right? And in that case, do you have a slashing mechanism if there is an unauthorized access?
Got it. I think you had two questions. You had a question which you're not asking now, which was how does the tokenomics plays in creating the company? And the second is how do you make sure that you play tokenomics in a way that you impact these malicious users, right? Fair. So I think the first one, the tokenomics and business part, I believe one of the strengths in a crypto company is the tokenomics. Why? Is that for a Web2 company to create the product and then have the adoption, getting the feedback, going to a good enough crowd needs a lot of money. Like I can make a product today in Web 2, and if I want to get it tested by 100,000 users, I have to spend immense amount of money. And if I'm lucky and I'm funded, majority of my early investment is just going there in that adoption and getting the feedback. Now, just imagine like nowadays almost all the projects in crypto are doing airdrops. Now, airdrops is not just about giving free money. Like they don't understand. Like for the builders and innovators, airdrop is a mechanism for getting their product tested in the market and getting the feedback in a very early phase, and where people are also motivated enough to come back again to test it again. And that bootstrapping of the network or any crypto product is basically enabled by the tokenomics piece, right? So it's a very, very important facet in any crypto project when they're getting started up. In case of deepins, there's another part to it, right? Which is, let's say you have 20,000 GPU demand, and they're being used. Fair. Now, let's say another customer comes in and he wants to use another 10,000. There are only two models. One is either you have a capacity already lying there unused, which a new customer can come and use, right? Or basically when the customer comes, you at demand time go and get it, right? Predominantly getting at that time and bringing in is slow, and a lot of times people don't warn in slowness, so you lose the customer. So you basically have the spare capacity lying there. If you own the inventory, you can eat up that cost. But the moment you own the inventory, it's not a lightweight model. It's going against the ethos of Deepin itself. So that's the second place where tokenomics play a very important role, that the spare capacity which you have in your network, where people will come in and look, oh, there are 1,000 H100, 1,000 4090s. Those unused hardware are being incentivized by token. And that's where the spare capacity and making sure that your network is big enough is being enabled by token. That's the business side of things, right? Now, coming to the bad actor question of yours. Now, in bad actor, like there's no magic. It takes some time. It took us a time. We basically built a proof of work. And you have to go through multiple iterations, because whenever things are about money, people are creative. When we were creating proof of work, like I've seen people going at operating system level, changing things there to mock the hardware. When the community is coming and saying, I'm having an H100, which is like more than $30,000 worth of hardware, people will give a very, I'll not say shitty, but a cheap device, but they will change everything in the OS and everything that looks like H100 and get incentive for that, right? People can become that creative. So making sure your proof of work becomes more matured over a period of time takes time. So that we invested in heavily. It took us time, and we had to hire like best of people in the world. Like we literally hired people from NVIDIA, Amazon, VMware, who knew the system, who had operating system background also to build this thing. So it took time, right? Then other thing is, we were lucky that the community basically loved us. So we got a huge amount of inventory in the very beginning. So we could do benchmarks on top of that, and we had good numbers in multiple facets of testing, that if a good hardware comes in, these are the numbers which look like for these tests, and for the bad one, this is how it looks. So then this is how we started to figure out, this person is good, this person is bad. Now how we actually even made it better was with the slashing and staking, right? So now for each hardware, depending on the cost of the hardware which people are giving in, we are asking the respective amount of stakes, so that if they're doing something shady, it pains them that they've given up the wrong hardware, right? So now we brought in that staking, and if our models figure out which have matured over a period of time, then we slash these hardwares. And the slashing is tough enough that people don't try these stuff anymore. And honestly, the tokenomics of ours is good enough that people are earning so much good incentive in terms of tokens that they don't want to lose this opportunity to be part of the network. So I think overall it took us time to be at this mature position, but it's possible, it's just painful and long process.
I think when you look at a Google Cloud or an AWS, right, and you compare that to the hardware that's connected to networks like ours, it's the same. Same GPUs, same locations, same network infrastructure, right? There's really no difference, right? So what is the difference, right? The difference is largely the token, right? This is this added X factor that we have, this added lever that we can pull to do really interesting things with the network that we're building, right? And you've heard a lot about what those things are here. I think in a very, very short snippet, because I see we're out of time, I think when you're thinking about how to utilize the token in your network, I think the trap is focusing exclusively on scalability. How do I take my token and use it to scale my network? It's really exciting to think of your token as just this reward structure that you can provide for people to join your network, right? But you don't want to screw yourself later on by having those same first movers that came in for that initial arbitrage as a result of that token reward, then departing your ecosystem later on because the rewards aren't what they thought they were going to be long term. So I would say instead of focusing on the scalability side, focus on the stability side and building kind of long-term reward structures in your network.
I absolutely agree. But I think you might agree, like, bootstrapping a project with tokenomics is one of the best things there in crypto. And if you don't take advantage of it, you're basically losing out on a very good value which this economics have given you.
You just have to do it smart.
I think Web2 companies stake their reputation, and in Web3, we stake tokens, right? They act as a proxy for reputation. So creating these kind of incentive systems to incentivize good behavior and disincentivize malicious behavior is very important. Thank you for talking about this. I think we are out of time as well.
Yeah,
Thank
thank
you.
you so much.